right, let's go ahead and get started with example 2. In example 2, we're going to be comparing precision and accuracy. And remember, a review of precision is the level of detail and measurement and is determined by the smallest unit or fraction of a unit that you can reasonably measure. And accuracy is how of a measurement is the closeness of a measured value to the actual true value. Okay, so let's go ahead and look at this. So at first it says Ida works in a deli. She is testing the scales at the deli to make sure they are accurate. She uses a weight that is exactly 1 pound. So we know that the pound, the weight that she's using is exactly 1 pound. So she has 3 different scales. Now when she puts that 1 pound weight on scale 1, she doesn't get 1 pound. She gets 1.019 pounds. So we know it's a little bit off, right? And then when she puts it on scale 2, she gets 1.01 pounds. So this scale is off by a little bit too. And then she puts it on scale 3 and she gets 0.98. So really all 3 scales are just a little bit off. So we're going to be looking at A and B. So the first thing it says, which scale is most precise? So when we're looking at this, they're all in pounds, right? So that means they're all the same. So then we're just going to look at the tenths, hundredths, and thousandths place. So this is the tenths, this is the hundredths, and this is the thousandths place. So this one gets measured all the way to the thousandths place. This one gets measured to the tenths and the hundredths. And this one gets measured to the tenths and the hundredths. So since scale 1 goes to the tenths, hundredths, and thousandths, that would be to the smallest fraction of a unit. So that means that scale 1 is the most precise. And then it wants to know, well, which scale is the most accurate? And to determine that, we need to see how far. We know that the true value is 1 pound. And these are all slightly off of 1 pound. So we need to see how far off they are. So I'm just going to take scale 1, right? And I'm going to take the difference. So 1.019 minus 1 gives me a difference of 0.019, right? So that's scale 1. We look at scale 2, and we get 1.01, 1.01 minus 1. So when we take 1 away, we're just left with 0.01. And then scale 3, I'm just going to switch because we're finding the difference. So I'm going to put the bigger number, which would be 1 minus 0.98. And we get 0.02. So the one that is more accurate is the one that is closer to 1, which would have the smallest difference. So out of all of these, we need to find the smallest difference. So the smallest difference, well, out of these two numbers, 0.01 is smaller than 0.019. And then, so we know that this one's smaller than this one. And then, so when we compare these, we know that 0.01 is smaller than 0.02. So this is the smallest. This is the smaller difference between 1 pound. So we know that scale 2 is the most accurate. All right. So let's look at the next example. Okay, and for this one, we have a standard mass of 16 ounces is used to test 3 postal scales. So if you went to the post office and you put like a package on, you'd want the scale to be correct because you have to pay them money for how heavy it is, right? And so if the scale is off, you might have to pay more money than you really should, or if the scale is off where it makes it seem that it's not as heavy as it actually is, then you'd have to pay less money, but that would hurt the company. So you really want the scales to be right, perfectly in balance, so it's a fair for the company, for the post office, and also for the individual that's trying to mail a package. So we have 3 scales, scale A, scale B, and scale C. and there's a 16-ounce weight that's being put on all three of them. Now, on this first scale, it's reading that the 16-ounce weight is 16.3 ounces. On scale B, it's weighing that the 16-ounce weight is 15.3 ounces. And scale C, the 16-ounce weight is being weighed at 16.07 ounces. So all three of these scales are off, but what we want to know is which scale is most precise and which scale is most accurate. So I'm going to give you a little time to work on there. Here's my friend, the pause dragon, reminding you to pause your device, work on A and B. When you get done, press play, and we'll go through the explanations together. All right, see you in a bit. See you in a bit. All right, we're back. Let's go ahead and see how you did. So the first one is which scale is most precise. So they're all in ounces, so it just comes down to what is the smallest fractional unit they got to. So right here, this 0.3, that's the tenths place. So this one goes to the tenths, this one goes to the tenths, and this one goes to the tenths and hundredths. So that means this one's more precise. So if you put scale 3C, you would be correct for the precise. Then we have to do which one is most accurate. Now, it's all the way down here on my paper, but just to keep it all in the same window, I'm just gonna move it up here. Okay, so that's my A, this is gonna be my B. Okay, so I just need to find the difference. So for scale A, I gotta find the difference in these values. So I'm basically gonna be going, you know, I can do it vertically too. 16.3 minus 16.0, and that just ends up with 0.3. That's scale A. And then scale B would be, what is that? Is that 15.3? That's 15.3? Okay. So this one's bigger. So it'd be 16 minus 15.3. So I need to borrow, making that a 5 and that a 10. And so that would be 0.7 difference. And then scale C, this number is bigger, so you put it on top. Minus 16.00. 7 take away 0, 7, 0, decimal, that cancels. And there you go. These are our three differences. So the one that's most accurate is going to be the smallest amount. So we have 3/10, we have 7/10. So 3/10 is smaller than 7/10. But this is 7/100, and 7/100 is smaller than 3/10 and 7/10. So this would be the most accurate. So which scale is the most accurate? We would say scale C. All right, so if you got both of those correct, you did a great job, and we will see you in a little bit for example 3.